All right, here we have what we would call an exotic particle. So a particle that's not really common, never before seen, and we will call these korsmitons. And when we come across these new particles, sometimes it's quite difficult to measure the mass of the particle. And sometimes it's quite difficult to measure the charge of the particle. However, one thing that can kind of be measured is the charge to mass ratio of the particle. Okay, so even if we can't get either of them specifically, maybe we can still get the ratio of them as we did for the proton and electron in the previous question. So here, this exotic particle, this korsmiton, enters a magnetic field of 5 times 10 to the negative 3 teslas perpendicularly with a velocity of 4 times 10 to the 6 meters per second. So it goes into this field. This field makes it bend into a circular shape, and the radius is 50 centimeters. Determine the charge to mass ratio Q over M of the korsmiton. All right, so let me list out what we know. We know the magnetic field strength. We know the speed. We know that the velocity of the particle is perpendicular with the magnetic field, therefore sine of theta term doesn't matter, and this is going to travel in a circle. We know the radius of the circle is 50 centimeters or 0.50 meters. So we're going to use the uniform circular motion formula. The centripetal force equals to the mass times the centripetal acceleration, where the centripetal force is provided by the magnetic force, which has a formula of Q V B times sine of theta, but theta is 90 degrees, so we don't need to write that. Okay, so that's going to equal to M, and then times V squared over R. Because it's going in uniform circular motion, the acceleration is V squared over R. So the magnitude of the velocity is the same thing as the speed. That cancels out with one of the V's from the V squared. And what we're isolating for this time is Q over M. We're isolating for Q over M. So not one letter, we're isolating for two letters at the same time. So how can I get an equation that looks like Q over M? Well, I can divide both sides by M. I've got my Q on the left side already. Now if I divide both sides by M, I'll get Q over M. And at the same time, I will divide both sides by B, the magnetic field. You divide both sides by B. That'll give me an isolated equation for Q over M. So I'll fill in the values. And let's see what that equals. Let's do some mental math here. We have 4 divided by 5, which is 0.8. We have 0.8 divided by 0.5. So that's like 8 divided by 5, basically. That's 1.6. And then our powers of 10, we have 10 to the 6 divided by 10 to the negative 3. Using exponent laws, that makes 10 to the 9. So the units are going to be kind of weird. You got meters per second on top. You got teslas and meters on the bottom. let's just take a look at what we're calculating though. We're calculating charge divided by mass, so the units are going to be coulombs per kilogram. Now, I don't know if this is a positively charged particle or a negatively charged particle. I only know the magnitude of the charge to mass ratio. If this was a negative charged particle, the answer would be negative. There's not enough information to know that. I could figure it out with the right-hand rule if they tell me the directions of these things, but they don't tell me the directions of these things. They just said they're perpendicular to each other. Yeah, so there's no way to know, or not enough information.